Hello students, welcome to the class. Now today we are going to discuss about the lab activity which we have in the 10th class, and let us see the aim of the lab activity. Observing types of images and measuring the object distance and image distance. So we have the understanding of the ray diagram children. So by keeping the position of the object at different positions, we could get the images of different nature. Okay, so that idea you must have. That idea will help us a lot in following what we are doing now. Okay children, and see the materials which are required to do the activity. A candle, or we can also use torch, a paper screen which acts like a screen children, okay, to obtain the images, and V-shaped stand and a concave mirror, see, of known focal length. Generally for this activity, that is for observing the type of images, we are using a concave mirror of known focal length, okay, right, and a meter scale. So I just want to show you all these materials which we are using children. So here, this is a V-shaped stand. This is a V stand, okay, and we have the concave mirror. This is the concave mirror which we are using for the activity, and the focal length of this concave mirror is 20 centimeters. Focal length is 20 centimeters. Okay, and next a meter scale. I have a meter scale, right? I have a meter scale here, and paper screen. Okay, we are going to use a paper screen like this. This is a paper screen children. So this is used to catch the image. Okay, right. Next is we have a candle or torch. So here, look at this apparatus. This is the candle children, and this mesh acts like an object. This is a candle, and this mesh acts like an object. Actually, this is called as an object. Okay, this is called as an object, and this is called as a mirror, which we are mounting the mirror on the V-shaped stand, and we try to get the image on the screen. Okay, so these are the things which you are doing, you are going to use in this activity. Okay, and I already told you that the focal length, the mirror which you are going to take here is of known focal length. Now how do you know the focal length is? Generally this mirror is going to come in one cover. On that cover it will be written 15 centimeters or 20 centimeters or 25 centimeters. Now on the cover it was written 20 centimeters. Okay, even if I don't have the cover, how to find out the focal length? Okay, roughly we can find the focal length of the mirror by distant object method. Okay, what is distant object method children? So you have to take the mirror, okay, and this is the screen. Okay, we should stand near the window or near the door post, and you have to focus the reflecting surface. Okay, you have to focus the reflecting surface outside where there is plenty of sunlight. Okay, and we have so many trees outside, we have so many objects. Let me say bus is an object or car is an object. So many objects we have. Okay, so what you have to do is we have to focus the reflecting surface onto the objects. Okay, and the light rays are coming from there, falling on the mirror, and it's get reflected. So this screen, what you're going to do is that you have to start moving this screen from the mirror. Slowly you start moving like this, and at one particular point we'll get a very clear image on the screen. Okay, so this is a case of the first case of the ray diagram children. That is when light ray is coming from the infinity distance. Okay, when the object is kept at infinity, light rays coming from long distance, and after falling on the mirror they converge at the focus. Okay, so this principle is used here. So light rays from the objects which are at long distance come parallelly and fall on the mirror, and the light rays are reflected and they are meeting, converging at the focus. So if you place this that is the screen near the focus, then we can see the image very clearly. Okay, now next what you have to do, you have to measure the distance between the mirror and the screen. So that distance I have found out in the morning, and I have found out that the value is 20 centimeters. Okay, it is already written on the that is cover page, on the cover paper, and not only that, I have done this activity also in the morning, and I could get the focal length is 20 centimeters. Okay children, so that's how I have written here the focal length is 20 centimeters, right? Now what we are going to do is, the activity is just to observe the types of images and measure the object distance and image distance. Okay, so already the f is 20 centimeters. So what I am going to do is that the first, the object distance I am going to take as 10 centimeters. I am going to take as 10 centimeters, and then when I place it at 10 centimeters, I am going to find out the image distance, at which point I am going to get the image, and then I have to measure that. We are going to do that activity now. Okay, now I am going to measure the image distance here, and what is the nature, is it enlarged or is it diminished, is it erect or is it inverted, that nature we are going to write here. Okay children, the first reading is at 10 centimeters, the second one is at 20 centimeters, at 20 centimeters, that is at the focal length. Okay, and the third is at 30 centimeters, is at 30 centimeters. So this is the distance of the candle from the mirror. Okay, right. Next 40 centimeters, and the last is at 60 centimeters. Okay, 10, 20, 30, 40 and 60. Okay, 5 readings we are going to take now. Okay children, and let us try to find out the image distance, right? And I want you to just look at the experimental setup here. So yes. Okay children, so let me keep the mirror at one end. I am keeping the mirror here at one end, and I am taking a scale, and I am going to measure children from the mirror. I have noted distances like 10 centimeters, here 10 centimeters, this is 20 centimeters, this is 30 centimeters, this is 40 centimeters, and this is 60 centimeters. So I am going to place this candle along with the mesh. So this is the object now. Okay children, so already we have seen that object is 10, 20, 30, 40 and 60. So first I am going to place the object here at 10 centimeters, and I will try to obtain the image, and then later on I will move it to 20 centimeters, then later on I will move to 30 centimeters, later on I will move to 40 centimeters and try to get the image, and finally I will move to 60 centimeters and will try to get the image with the help of the screen. Okay, and wherever I get the image, okay, I am going to again measure the distance from the image and the mirror. That will be the image distance. That is what you have to note down in this activity. Okay children, so we are going to start this activity, for which I have to switch off the lights. Okay children, so we have switched off the lights, and now I am placing this object at 10 centimeters from the mirror, and if you keep exactly like this, we won't get any image children. Why? Because you have to make a little bit adjustment like this, so that the light ray will go this side and get reflected here, right? Now I'll try to get the image on the screen children. So this is not the image what you can see. So this is not the image, okay, and this is not the image. You have to get the mesh. Okay, the mesh is the object. Okay, so as I take like this, so there is no chance that I am going to get it. So generally this is the case when the object is placed between the focus and the pole. You are not going to get the image in this case children. Okay, so generally we get a virtual image in this case, right? Hope you understand the ray diagrams which we have drawn. Okay, now we'll go to the next, that is we'll place it at 20 centimeters, that is here. When we place it at 20 centimeters, that is at focal length. Okay, you are placing it at a focal length. Now let us try to get this. Now here also you can see that, please come closer. So here you can observe actually at very long distance you can see the image, children. Please come. You can see the image. I hope you can see the image. So this is the image. I hope you are able to get it right. So this is the image. See, it's a very magnified image of the mesh. Please keep in mind that's not the, don't concentrate on the light, but you have to concentrate on the mesh. Why? Because the mesh is the object. So when the object is at focus, focal length, that is 20 centimeters, we are getting the image at very long distance, that is at infinity. Okay, so right. So I am noting down all these values, children. Later on I will write on the board. Okay. Now I will move the object to 30 centimeters. To 30 centimeters. Okay. Now try to get it, children. So this is not the image. Now okay, see this, take it more closer. Did you see the image, children? That is the image of the mesh, and it is very enlarged. It's a magnified one. Okay, so at when the object is at 30, you are getting a magnified image, and I have to measure this distance, that the distance between the image and the mirror, and it is almost 60 centimeters, children. When the object is at 30 centimeters, image is obtained at 60 centimeters. I can see from here this distance is 60 centimeters. This is 60 centimeters. Object distance is 30 centimeters. Image distance is 60 centimeters. Okay. Now next I will take it to 40, children. I'm taking it to 40. Okay. Now let me try to get the image here. See, children, both the object and image are side to side. Okay, so that is when the object is at 40 centimeters, image is also at 40 centimeters. And look at the size, both are same. That is the size of the object and the size of the image, both are same. Okay, children, now next I will move it to 60 centimeters. 60 centimeters. Look at the diagram, look at the image, children. It's very diminished, and okay, we may not be able to get it in the camera. Actually the image which is formed is very diminished, and we can see very clear mesh, children. Very clearly we can see the mesh. Actually we can't see in the camera, right? Okay, so now when the object is at 60 centimeters, children, the image is obtained at 30 centimeters. Now this distance, this is 30 centimeters. Okay, so this is a small attempt made to explain the lab activity, children, to you. Okay, children, I hope you have followed our activity. There was some inconvenience, but still I tried my level best to show to you. And at 10 centimeters, we couldn't see any, we couldn't find any image, right? So we can't write any characteristic features. Why? Because that was a virtual image which is formed. Okay, and at 20 centimeters, when it is 20 centimeters, so the image was formed at long distance, so that was infinity. Okay, and it was very enlarged. It was very enlarged and it was inverted. Enlarged and inverted. Okay, now coming to when it was at 30 centimeters, I got at 60 centimeters. The image distance was 60 centimeters. And it was a enlarged. What is the difference between these two? Is it is highly enlarged here. Highly enlarged. This is enlarged and it is inverted. It is inverted. Okay. And coming to 40 centimeters. When it was 40, we could see that they were side to side. So here also it is 40 centimeters. Okay. And here object distance. Sorry. Yeah. This is a object size. Object size is equal to image size. Image size. Okay, it's inverted. And when it was at 60, it was at 30 centimeters. Okay, and this is diminished. This was very difficult for you to observe. Okay, that was a diminished. And it's inverted. And inverted. And like this, if you take it to 100 centimeters, if you take it to 1 meter, if you take it to 2 meters, that is object at infinity, then you will be getting this image distance. That is at, you will be getting a focus. Okay, and that will be very diminished, and it will be it will be very highly diminished. Okay, and it will be inverted. And the first case, that was 10 centimeters. So this was a virtual case. Okay. So these are the characteristics which you have to note down. This is very, very important. Okay, children. Now, suppose we are doing this activity like this. You have taken at 10 centimeters, 20, 30, 40 and 60. And let us suppose that you do not know the focal length. Okay, and we noted the U and V. So how do you calculate the focal length? Okay, so calculating focal length. Okay, so object distance you have noted, children, and you have noted the image distance. 1, 2, 3, 4. Okay, for the 10 centimeters we didn't get it, so 1, 2, 3, 4. So let me say 20 centimeters, and at 30 centimeters, at 40 centimeters, and at 60 centimeters. At 20 it was at infinity. Okay, at 30 you got at 60, at 40 you got at 40, 60 you got at 30. Okay, children. So how do you calculate the focal length? We have the formula, mirror formula. That is 1 by f is equal to 1 by u plus 1 by v. We can substitute and we can find it out. Okay. So 1 by f is equal to, so 1 by minus 20. Hope you didn't forget the sign convention. Plus 1 by infinity. 1 by infinity is 0. Okay. So this implies 1 by f is equal to 1 by minus 20. What is the meaning of that? F is equal to minus 20 centimeters. Okay. Minus 20 centimeters. Now here 1 by f is equal to, okay, 1 by minus 30. Okay. Plus 1 by minus 60. Okay, so you are getting LCM 30, 60, 60. Okay, right. Minus 2, minus 1. So you are getting here minus 3 by 60. Okay, ultimately, what is that you are getting? F is equal to, you are going to get F is equal to minus 60 by 3. Okay, so you're getting how much? Minus 20 centimeters. You got here minus 20 centimeters. Here also you're getting minus 20 centimeters. And if you see here, 1 by f is equal to 1 by minus 20 plus 1 by minus 20. No, minus 40, sorry. U and V are 40, right? Minus 40. Minus 40 and minus 40. So, how much you are getting, children? 1 plus 1 by minus 40 is equal to 2 by minus 40. This implies what is that f? F is equal to minus 40 by 2. Minus 40 by 2, you are getting minus 20 centimeters. So, you are getting minus 20 centimeters everywhere. Okay, children. And again, 60 and 30. So, already we have done here 30 and 60. We already got here minus 20. So, here also you are going to get f is equal to minus 20 centimeters. Understood, children? So, u was the object distance and v is the image distance. And by applying the mirror formula, we could calculate the focal length. Okay? So, when we get this focal length, so as we got the same focal length, so many times we won't get the same values. It may be 20 and sometimes it may be 20.1, it may be 19.8. So if you get like this different values, what you have to take is you have to take average of all that. Okay, you have to add divided by number of times you have done it, and finally you will be getting the average focal length. Okay, so in this today's class we have studied, that is in the first lab activity, what we have studied, you have studied about the nature of the image when the object is placed at a different place, at different positions before the mirror, and we have written all the nature of this. Okay, children. So by keeping the ray diagrams, okay, by studying the ray diagrams, we have learned all the characteristic features. So to compare this table with the ray diagrams, so the understanding of the ray diagram is very, very important. The knowledge of ray diagram is very important, and then when you compare these diagrams, so you will very well understand the ray diagrams. Okay, and this is how we are going to calculate the focal length. If you do this lab activity and you find out the object distance, you find out the image distance, then by substituting in the mirror formula, you will be able to calculate the focal length. Okay, children, I hope you have understood this lab activity.
Tell me pretty lies, look me in the face, tell me that you love me, even if it's fake.